All right, so actually I think probably the way I'm mostly interested about alternative methods of managing distribution and timing of grazing. That's kind of my favorite, because I think, really, if you take a look at this, I mean, why do we even worry about where they graze, right? Is this really our optimum grazing management? Is that what we really, really want? You know, I mean, do we really need to do that? I mean, that's perfect, isn't it? That's awesome right there. I mean, because we do that, we want to control the time, duration, frequency, and intensity defoliation. These guys are doing it, the livestock are doing just what they want there, right? But we can't do that because the thing is these dang livestock are selective. And they're selective at multiple scales. I mean, the first thing is I mean, they're selective, they bite different things. I mean, and what they're often trying to do is to get more nutrients, avoid toxins, try to get some more biomass. They can also be selective by feeding station, and so they don't have to just select one plant. They can kind of decide on where they move their feed in a kind of a real small scale. They can move from one of these to another one, and that's feeding station, but they're still kind of looking for the same thing. They want to have plants with a lot of nutrients, they don't have many toxins, and have some biomass. And they can even get another bigger scale, get up to patches. You can kind of like have this sort of scale like this. These cows could select for. Still though, they're still looking for a lot of nutrients. They want to avoid areas with a lot of toxic plants, and they want to get some biomass. Now as you get just a little bigger, you start thinking about feeding sites, and feeding site would be a place they would go between water vents. So they go get a drink and they go decide that. Something bigger, something larger, they would select maybe once or twice a day. Then other things start to pile up. They still want to get nutrients. They still want to avoid toxins. They still want to get some biomass, but they probably don't like to go a long ways from water. They don't want to go up steep slopes maybe. That may be a problem. And there's some other barriers. So these things are all issues. These darn things are selective. So what are we going to do? The problem is that dang things don't do all the time what we want. Now these guys are definitely not doing what we want them to be. And they're not being environmentally friendly at all. So what have we done? One of the things we've done is create grazing systems to manipulate the timing, duration, and frequency of grazing. That's one of the things that we have really got to do. So we have lots of fences, and we do lots of things. But it's fencing, I'm saying fencing is not without its problems. I mean, it costs a lot of money. I mean, it constrains wild horses on public lands. I mean, gosh, constrain big game. People worry about fences with sage grouse. It's not without its issues. And I can tell you, you're going to find out real quick, you know, there's some people that are recreational fencers, but I'm not one of them. Okay, now the thing is these intensive rotational grazing systems are expensive. There's a lot of initial costs, there's maintenance, there's potential one. Now this is from Australia, from not a small scale. Okay, we're not talking about 20 acres, 30 acres. They like to talk in square kilometers. This one was 40 square kilometers, divided into about 16 paddocks. These are not small. They did a study, and the second this study was up, you can see here this was lane 4. The second this study was up, they rolled up those fences immediately in Australia. The thing is, because it cost them about one person full time just to maintain this operation. So there's issues. There's issues about it. And then we have the Brisky paper. You know, the big elephant in the room, that says there's really probably no real big advantage in livestock performance or vegetative responses. And so, you know, yet they're very, very popular. And you guys are going to beat me up, and I'm ready for it. I got my track shoes and my car's parked out running, so I'm ready. I think it's because there's some fears. And maybe those fears are justified, but I mean, you come out here and here's this nice grass plant, this poor cow goes and eats it off, goes off, and Justin talked about it, and dang if she doesn't come back after a regrowth and eats it off again. Man, that's a problem, right? So one of the things we have to start thinking about grazing systems where we don't want these livestock to have that opportunity. so that you want to move them within thing. And they're doing it now in the University of Arizona at the Santa Maria Range. They're just starting to evaluate a grazing system where they move at least within about 10 days so that there's not sufficient time for that plant to regrow and then to come back and take a bite off of that. That's the thought process. So that the thinking that in this short period of time that you don't want to give the animals the chance to go back and regraze the regrowth. So they keep it very, very short. Now, I don't think this always occurs all the time. And one of the things is because I think it's, to me, and this is not my expertise, but what I want to do is try to give you enough, just keep you stirred up and alive. And secondly, to keep you interested to think about some of these other things and keep the discussion of this going. First of all, for rapid growth, you've got to have some available soil moisture, and this works in higher rainfall areas. But I'm not really there. And here's where I think it's very important. This kind of regrowth can occur in a riparian area, and I agree with that. And so you do not want to graze continuously in a riparian area because there is sufficient moisture for regrowth for this to occur. And so that continuous grazing, there's a lot of research about it. This thing can really occur in a riparian area. So this type of rotation can be very beneficial where you have it in higher rainfall areas, in places like riparian zones where this occurs. It can also be, kind of this regrowth could occur in a good precipitation year. But you also got to have favorable temperatures. So you have two conditions. You got to have a lot of moisture, and you got to have favorable temperatures for this to occur, like a long growing season, those sorts of things. But where I hang out, especially now that I'm in Las Cruces in the Chihuahuan Desert, there's not that much soil moisture. It's usually limited. It's often pulsed. It works, so I'm saying, I think this kind of rotational grazing can work well in areas with lots of riparian areas. You get a lot of improvement in showing in that situation, in my thought. But in good years, it might, you have this regrowth, but usually there's so much forage around in those sort of years. I mean, usually you can't get enough animals to eat it, so it's really hard to even see it goes around. And when you have a lot of cool season grass ranges, often the temperatures can get hot and you lose that growth. And in warm season ranges, once it gets growing, it can get cold and stop that growth. So one of the things is I really want you to stop and think about, when I talk about some of these other things, think about what Pat Reese, Dr. Reese told us before. He said, one of the things about these rapid rotation, these kinds of fast rotation grazing seasons, do they really provide rest during the active growing season? I contend that's probably not the case. If you have these pastures divided too much and you move and rotate, you're going to graze every time something in the active growing season. You're going to do it. So what I'm not saying is that I'm not saying that continuous grazing in this discussion is beautiful, but what I am saying is it's probably deferment in the active growing season may be the key. So let's talk about some of these other ideas down the road. So when we talk about distributing cattle around and things, think about it a little. You can stay mad at me, but think about it a little bit. Second fear is patch grazing. And definitely patch grazing is a bad thing. It's for sure a mechanism for rangeland degradation. So if you have these little patches like that, I mean, it kind of bothers, it's grazed down, the rest is not, kind of can be bothersome to people. Now you can get rid of that. So take a look here. I mean, you can get rid of that. And now, so I got this from Australia. And so this is not overgrazed, this is not smoked, this is flogged. Okay, so you can get rid of these problems. But can we manage selectivity? Can we do it? One of the things is here's the big one we're going to talk about. Heterogeneous grazing distribution on bigger paddocks. Now we have a few bigger paddocks in Las Cruces at our research center, and the theory is here, and this is the desert, but you're worried that they're going to be hanging out in these little green areas, and these little preferred spots like this, and not getting out here. That's the worry, not getting away from water. That's what we're worried about. Can we manage that? Now here's the key. So you can, so as you're getting mad at me, you can say, okay, I think the answer is, when we think about grazing management, we've heard about it from the plant level. We have some really great stuff, and I'm really not the greatest plant guy. But you can see I've been hanging out. You can do where I've been trying to get some information is, what can we learn from the cow? What does this grazing management do to the selectivity of the animal? Okay, for example, on fencing. Now, one of the things with fencing is you could divide it up, right? So you can see how we could split it up, and this is how my grandfather would have told me to do it. Kid, get out here and divide it into nice straight fences, equal blocks, and you just divide that up and so you could have a nice rotation system. But what have you done when you fence that way? Now you have, and the way thing is, if you look at it this way, here you have, like, maybe imagine this is like a steep hill, riparian area, so green's good, kind of intermediate areas. So when you divide it, you still have the same situation. You still have a heterogeneous spot, and you may not have much effect on distribution. Maybe. But what if you did it this way? Divide it around like this. Then what do you get? You get a riparian pasture. You've increased the homogeneity of that. So if you want to use fencing to do this, I'd say try to think about that, and think about trying to fence in like areas. If you have a crested wheatgrass seeding, if you fence in the seeding away from native range, it'll be easier to manage. That's sort of an example. If you have a riparian area, you fence in a riparian pasture, it's easier to manage. The choices are more uniform. Now, so if you can do some fencing like that with grazing, I think that can be some very beneficial things. One of the things, we have a little bit of data to support that. Some work that I did when I was in Oklahoma. We had a very homogeneous, we all had been grazed, equally grazed off fairly well. Here we had one that was ungrazed and fertilized with a lot of nitrogen and grazed. And notice that the time they spent in a homogeneous spot was pretty similar, and there were some definite preferences when there were big differences between the landscape. So preference, if you have very different places, you're likely to show preferences off more than if they're homogeneous. Now, what about this? This is the savior, right? We have a bunch of cattle, a bunch of animals out here in this big paddock, the whole distance to water thing. We put in more, we put in some fences, and we divided it up. Now, stocking density. What have we done to the animal? Let's look at that. One of the things that in my opinion, I kind of disagree a little bit with Justin. I don't think that the data suggests that the uniformity of defoliation is really that affected by system, at least by stocking density anyway. It doesn't literally look like that in this is the recent one, Barnes. They think it does, but I didn't. When I interpreted the data, like Dr. Kruger said, I didn't think it said that. So, and I think he said it too, but still they liked it. So they're kind of pro-intensity. But there's some other data that suggests that is the case. Here's a partial explanatory thing. This is from data from Dick Hart. He was on my graduate committee. So there is some, you can tell that maybe you'll be able to tell that later on. He did a study where he was looking at that. So he had a very long continuous where he had distance to water is obvious a question. So he had water here and the cattle could graze around. We have different colors of utilization. And he had a rotation system and just small pastures. And lo and behold, he found that as you moved away from water, the utilization went down. It wasn't, so it really, he says it's really that stock density in and of itself may not change so much unless it changes the distance to water or the pasture size. That was his conclusion. So it's not density in and of itself that can make the difference. It's how you change the spatial arrangement of things. So here's some neat data that Barry Irving did up in Canada. Now these were fairly good paddocks. So they're long and narrow. It's like up to 2 miles from water. Oops. Up from 2 miles from water. So that was the blue line. This was close. So they had long, narrow pastures, and they watched what happened over 5 days. And what happened is right close to water got grazed up to about a moderate level. Then they started moving out further and further and further. So when you looked at it, it looked like, hey, we got even grazing. But what you had done by increasing, he argues, and I argue, that what you have done by increasing stocking density has accelerated something that would have occurred over time at a longer grazing period. By increasing stock at a lower stocking density, you've collapsed it in time. The same process is occurring, you just collapsed it in time. So because you really want to do it. The motivation of the animal is they're running out of food here close, so we'll walk out further. What have you done to the animal? What do you do by that change in that? Now, one thing for sure that you can do, though, here, look at this as an example. Look at there's a fence line contrast for you, right? Now, this one has, I can guarantee you, has had some high stocking density and definitely got to graze, some seriously grazing use on a very steep slope on the left-hand side. They did that, and they definitely used less preferred species. They traveled further up and used steeper slopes, but it came at a cost, right? Animal performance for these is definitely probably lower. This is in Mexico. On the right is a university research ranch, and left is just some villagers there. There's a big difference in performance. If you push them that hard, you're very, very likely, there's lots of literature to support, you're going to have a decrease in performance. And a lot of ecological risk. If you're willing to push it, if you want to use grazing pressure to graze it uniformly, it comes at a big risk and maybe a big change in performance. Now, what else can we do? We can do water developments. I'm always proud when I show this one of a cooperator at Ray Hartley's in there. This is an optimum one. But, and I think they can do a lot of really good stuff by developing things. If you, I can, look at here. So this is, so you can plan water, don't do this, right? Now I can tell you that this did come from a university ranch, not one that I'm still employed at, but I moved the water out, and we got an improved thing. So use a little brains when you do this, and there's some good data out of University of Oregon, out of Tim Telgrotto's crew, Parath et al., that if you put off-stream water, you can change what animals do. So basically, if you put off-stream water, you can get them to move away from the riparian zone when they're coming into water in the heat of the day. And that information looks really good. It's a really good thing. They even got an increase in performance out of that. So that was Oregon has done some really good stuff on that it works. So it changes where they graze and especially where they rest by putting off-stream water. Now, season of use can be a big difference. Now, this is there's two things that's kind of introduced it. I always like to do that, and also give you a little indication of why I moved down to Las Cruces from Havre, Montana. But there's also some good work that Corey Parsons and Oregon State did out at Union, noticing that if you change the season of grazing, like Dr. Kruger mentioned earlier, you can really make a big difference, especially on riparian use. If you graze it early, when the vegetation is all fairly green, uniform, you get a lot more use in the uplands and less, and as it dries out and gets hotter, more and more use. So changing the season of use is a very powerful tool to use for management of western rangelands. But we also think that choosing right animals are important. We think there's another tool that we can use, and obviously these guys are not the right ones, right? So one of the things is we thought about using the right animals. Can selection be effective? Some work we did when I was in Montana, we looked at animals we thought were hill climbers versus bottom dwellers and measured their utilization patterns, thinking that cattle that hung in the bottom may stay hanging in the bottom. Cattle that climb up the hills might stay up on the hills. So you cull the ones at the bottom, you might make a difference. So we did that study, so we split up that same pasture, and we found, this is just 2 cows, but we noticed that there's still a big difference even though they were separated. But that's just 2 cows. But the big question is when do you think, if there was a difference, and obviously I'm hinting it from the previous slide, when do you think is the big difference between this? And so if you had some animals in there, would it be when they first turn them into a paddock or as you pull them out? Anybody think about that? I mean, I thought, God, I bet as we get tougher, that'll be the big difference. But it turns out that's not the case. The big difference was early on. When we first turned out, our hill climbers still climbed to the top and used some of the highest and roughest ranges further from right when we turned them out. And as it got grazed off more and more, even the bottom dwellers began to climb up the slopes. But we found some animals that did it right when we turned them out. They just liked it. They thought, they just really liked to climb. So we found some really big differences, big enough to change the stubble heights in riparian zones, in paddocks that were grazed with hill climbers, we ended up with 5-inch stubble height as opposed to 3 inches. And as you all know, the difference between 3 and 5 inches is a big deal. 5 inches kind of meets most riparian management standards. 3 inches doesn't. So we think that by picking the right animals might make a real measurable difference. Real measurable difference. Also did some breed work in Montana. We looked at Tarantays from the French Alps versus Hereford, more gentle terrain. We saw consistently 2 years in a row. Each color of bars is a different year. But as you change from straight Hereford, 3/4 Hereford, half Hereford, a 1/4 Hereford, straight Tarantays, a consistent pattern. So we think that breeds developed in more mountainous terrain, which makes a lot of sense, might do better. Now that's kind of old hat. We got a new study. Now I'm in Las Cruces. We're looking at Brahman, Brangus, and Angus. We have our Brahmans, Brangus, that's 3/8 Brahman, 5/8 Angus, and our Angus cattle, which are also developed in pretty extensive hot, dry climate, a little further north in central New Mexico than down in Las Cruces. We brought them out. Now this is a pattern, and so the values are the average distance of animals in there, and you're looking at 2-week periods in each one. The animals weren't together, but we did a Latin square, so we rotated the animals through in 3 different pastures and rotated them around, and compared each breed in each pasture, and then we just pull in the data here. But what I want you to look at is that notice that the Brahmins look really good over here in this paddock, not so bad and not so great over here and here, but they still made one long trip out. Angus didn't do too bad, except in this pasture. Brangus hung in there. But these Brahmins have this pattern, this weird pattern. Watch the next time we did. This was in the winter. This is now. It's hot. It's dry. And so in Las Cruces, we don't get spring moisture. We especially didn't this year in 2008. And notice that you see the same sort of pattern. These Brahmins are still wanting to go this way. In fact, in the last one, which I don't have quite pawed up, that we did later, actually got out here and went back there. We think that Brahmins are maybe more habit forms, since there's big differences, but the breeds wasn't straightforward as simple as I thought it might be. But there is some potential breeds effects in that, but that Brahmins may be more creatures of habit. We're going to continue to look at that. But is it just a matter of breed? You know why some cows walk the extra mile? This is what some more data that we came up with. Remember, we looked at breed. We looked at this, and we made a conclusion when we looked at Angus cows sired by Angus bulls, Charolais bulls, Piedmontese bulls, and Solera bulls. We made the conclusion that Piedmontese did really well. Now, each one of these bars is figured this is like a rate distance from water, so 0 is herd average. So, boy, this one did really good. And so from that, we concluded that Piedmontese were a pretty good breed for walking away from water. But if it hadn't been for this bull, we wouldn't have thought that. Look at the Angus, a lot of them not too good. One was better. And we wondered why the Solera turned out intermediate, because we saw a lot of Solera cows a long ways from water. And now, when we first looked at it, we didn't look at the bulls. Look why. There's a huge variation. Now, we need to do a lot more work. But the only difference between these are each bar represents daughters of a single bull. At least 3 daughters. Now, if we hadn't looked at what the effect of the bull have, we just have the same breed thing we did before. But what this is telling us is that if there's a big difference just between the bull, and we randomly mated bulls to AI to different cows, there really ought to be the only thing that can be accounted for that difference is genetics. And so if we can do some stuff with genetics, who knows what we might be able to do. Now, the other thing is, take a look at this. Now, livestock are moved frequently, and typically we always think about like this or maybe like this. Now, when gas was about $4, we were thinking about like this. But now that's oil, we're getting back to $2 diesel. It's more looking like, like this. But they're definitely moved around. We had a situation because of the drought. We moved some cows from the deserts of Las Cruces to East Texas for 3 years. And we also brought some cows that were born and raised in Texas and brought them to the Chihuahuan Desert. Now, these are very, very different places. Now the cows that were born and raised in Texas and the cows that visited Texas, I mean, that's like 41 inches of annual precip, 9.5 inches precip. Now, when they're both Brangus, they had very similar pedigrees. I mean, they both herded on horseback, but you can tell there's some big differences between those two spots. We looked at it 3 different times. We looked at it in the winter when the cows were dry, not lactating. It was really hot and it was really dry, but cool. Very low quality forage. Early summer, the cows had calved, they were early in lactation, but it was hot, like at least 90 plus, but very, very poor quality forage. And we also looked at it as the cows in late lactation. We get our monsoon, and it was very, very wet. Here's me moving some cows. Now, this is something you don't expect to see in the Chihuahuan desert, but it's having to move cattle through puddles of water is not a normal thing there. Here's the sort of thing that we found. So if you look at that, the naive cows from Texas, now these cows were separated again, they were never together. And even the cows that the tourist cows had been moved away, these native cows, but they had never been in these pastures, these 3 pastures, ever before. The tourist cows, the ones that visited Texas for 3 years and came back, native cows that stayed there, they had grazed adjacent pastures, but not these. And these poor cows from Leona, Texas, at the Mountain Creek Ranch, when we dropped them off at the College Ranch, they were used to small little paddocks, Bermuda grass, 41 inches of precip. We dropped them out in the Chihuahuan desert, and I was expecting they would run off and head back to Texas. I mean, I thought that, and we had fixed fences all through these very large paddocks, about 9,000 acres. But instead, what happened, they never went further than 300 yards from water. Not once in 8 days. Heck, they didn't even know that 4-winged saltbush was food, and they just would walk right past these beautiful bushes. And so consequently, they spent a lot more time, a lot closer to water. They eventually started moving around a little bit more and more over time, and then we looked at them again in the summer when it's hot and dry, same sort of pattern, but the naive cow started moving further and further away. But still, on average, there still looks like an advantage of the native cows. Tourists didn't do too bad either right there. But then when it's productive, those native cows still keep going out far away from water. And so when you looked overall, there was a big, big advantage of the native cows over the naive cows and how, in the distance they're willing to walk and utilize the far ends of those pastures. Now, how far is that? This is like, so these cows are going out about 2.5, 3 miles. It's pretty level terrain, but to them, Justin had mentioned there, like a 1/4 of a kilometer or something. I mean, these cows haven't even got stretched out by that distance yet. So, it kind of depends. What I'm trying to say is that those things are true, it actually happens, but it depends on the animal. Not all animals are created equal. So, how did they do it? Interesting enough, I first thought that, surely when we measured how far each group walked each day, I thought, well, surely the native cows are just walking a lot further all day, each day. Surely that's what causes. That's why I got a bigger distance to water on average. That's what occurred. But that's not what the data said. The data said that each group walked about as far. But these native cows that had been, the hometown girls that had stayed at home, they stayed out even in temperatures of 95 plus degrees. They stayed out for 24 to 48 hours at a time. Consequently, they spent more time away from water, and on average were a lot further away than there. So we think there may be some real physiological differences that's occurring there. So not only do we think the genetics is important, obviously learning is, and it fits with a lot of the work that Larry Howery and Fred Provenza did, that experience early in life can play a role, and so can maybe even recent experience can play a role. Now, interesting enough, we also measured, with fecal NIRS, we looked at the crude protein content. So this is using the Stuth approach, and we noticed that one of the things is maybe not too surprising, is that if we looked, the naive cows selected a poor quality diet in the winter when it was dry, very dry, extremely dry year. Also early summer, really dry. They selected a lower quality diet than the cows that had been raised there. Now the cows, whether they had stayed there the whole time or not stayed there the whole time, didn't make much difference. In fact, they were almost similar, very similar, statistically not different. But a naive animal just could not select as good a diet in drought conditions. Why? Probably because, perhaps one explanation might be, in those ranges, to get a higher quality diet, you got to eat browse, and for the longest time, they didn't even know that browse was food. But when it rained, the cows from Texas selected a higher quality diet. So in a really good year, it rained twice our normal precipitation in 2 months. So it was a very good year. When it was a lot of grass, really good year, cows that were used to a high quality diet did at least as well and better. They did statistically better, at least at 0.07, than cows raised in the desert and were probably really tuned up for selecting diets in poor conditions. So it's interesting. Experience can play a role. So that consequently, maybe this sort of thing is not too surprising. You probably ought to select replacements from those raised in identical pastures. That gets rid of the issue of the Brahman not being used to it, or from similar areas so they're used to the similar types of terrain and types of vegetation. That's really probably a very big thing. Now, kind of last thing is don't give up on adaptation. Our colleagues in Florida have very big success as well. So I think there's a lot of a potential for cattle to adapt. Now, a second thing I think that works is strategic supplement placement. We think we have a lot of good luck. So what are you doing with that, with animal behavior there? What are you doing? The thing is we typically, cows don't like to walk away from water. They don't like to climb slopes, but they do like supplement. They just love this stuff. And so if you put it up there, high on a ridge, away from water, they'll cruise up there. And once they're there, you've taken away all the issues, and they'll graze that nearby forage. It's kind of like me. If I head to a place for my supplement, mine tends to be liquid, barley-based, malt-based, at pubs some distance from campus. I'll eat almost any kind of free food that's around there. Now, I wouldn't go there if they didn't have my supplement. But my supplement's there, I'll go, okay? So once you get them to travel, you get them there, those issues are no longer there. Think about that. So you have changed the animal's perspective. You've done something to their behavior by doing that. Here's some data from the Hartley Ranch. Normally we think that utilization decreases as you move away from water. Justin showed us that, and I believe that too. But when I looked at the data here, lo and behold, the least amount of utilization in this study was right next to the water tank. As you moved away from water, utilization increased. Now that's not normal. It kind of scared me till we looked at it and we changed around, looked at it. What happens is that we put the supplement away from water, these low moisture blocks away from water, and they were attracted to them, and so actually the utilization was much affected as you moved. Rather than water is the attractant, supplement was the attractant, and we actually got the utilization decline as you moved away from the supplement, which is placed away. Now, this was done, it's not hot, it's in the fall, they need the protein, the grass is dormant, but it worked good. It was a powerful tool. Another example, more visual example, we put out supplement on this as high as we could drive up on this mountain here, and we turned the cattle, we showed them up here. This is one cow, 10 minutes, 10 days. We put the supplement up here, little black dots, and then we watched where she went, and we took the supplement away. This little trail happens to be the day after we took it away. She went up, it's gone, she never came back. But notice it's not perfect. We found some results earlier that 600 meters about the impact here. This is a 640-acre pasture. It's about a 1.25 miles here. But it's not perfect, but you see there's a difference. You can just see it. You don't need statistics to see that. Now, what else happens? Here we did it. We put the salt out first. We herded the cows up to the salt. Here's a 600-meter area. But compare it to here where after 10 days later, we put the supplement back out. And you can see a big change in this use area. It's not like you just tighten them into this, but it changes. It makes a big difference. It can make a big difference. So we think that's a very powerful tool. Another powerful tool that we've worked with is low-stress herding. This is one of the people I worked with in Montana. This lady here had never been around cattle in her life. They only ridden a horse a few times, and she's on a 22-year-old horse with legs like this. And I was so excited. She brought the whole herd in by herself. I had to screamed on the brakes and took a picture. I still bragging on how she did it. We kind of showed her how this Bud Williams low stress handling is, and boy, it seemed to really work for her. As opposed to here, now this is how I went at another unnamed university that I used to work for, that we had it. This is just part of the cowboys. Of course, I was back there. There was a couple guys in front, a couple more guys off here to move 200 head of cows about 12 miles from our winter range to our summer range. It used to be that sort of thing. By the time we got trained, it got to be like 3 of us, and that was mostly just to run the cows out of the way. So this is not, when we think about low stress, this is not it. This is not low stress herding. We did a study in Montana to try to improve riparian areas, and I want to just show you this, just that there's some power. Even the big issue, the big riparian issue, there's hope without a fence. We did a study where it was herding to a supplement, to low moisture blocks, or just herding to salt. The idea was to get them out of riparian areas like this, and to try to get them to save our riparian areas. So we herded them away from about noon. It's getting hot. Cattle get a drink. As soon as they get a drink, we gave them about an hour, and then off they went at noon. So they usually come in between about 10 to 11. They'd get a little time, and at noon we herded them off, took them to an upland like that, and settled them down to the calves to down, which didn't take long when there was low moisture blocks. The idea was to get them away from water so they wouldn't spend the whole day next to the stream. Did it make a difference? This is actually the raw data of the stubble heights of the average in here, and notice that the control, the free roaming control, was always lower than the herding or the herding supplement. And this is N of 9, so I'm pretty happy with 0.07. So, but it made a big difference in the stubble heights, but probably the best one is to actually look at the raw data. I mean, some of you may have seen this before, but it doesn't hurt to look at it again, I don't think. Take a look. This is a free roaming control in pink. The streams are in blue. These are about 1,200 acre paddocks, about as big as I could pull off at the Bear Ranch, as big as they let me pull off. This is a 600 meter area. Now what I want you to do is only 1% of the time so the next 2 years we're going to herd them to this spot. But this time let's clear roam. We would have had 1% of the time. Here we herded to this spot with supplement, 16%. So watch these two the next years. Okay, 2003. New set of 2-year-old heifers. We can change from 1 to 32% by herding and supplement. Pretty impressive. Herding still worked. We got a lot of herding away. Still a lot of cattle away from this stream area that we were trying to get them from. Now when this becomes the control, not much area. It goes down to 6% of their time there. This still stays at 22%. So the bottom line, we really changed where they went. We did this in the worst time we could do it. It was in the heat of the summer, when uplands were dry and riparian was green. We tried to find the worst time we could do it, and it still made a big difference. So I really get excited about that. You don't have to have a fence to have a big impact. And in areas that we did that, one of the things is it didn't look like that the supplement played much role on the use of the riparian areas, but boy, it made a big difference in keeping the cows where we herded them to. Big difference. Almost double the utilization in the target area within 600 meters of where we put the supplement. So herding kept them out of that. We conclude herding kept them away from the stream, but the supplement, low moisture blocks, tended to hold them where we put them. So we got excited about that. And kind of the last thing is we got so excited about it, we did another study and we started thinking about prescriptive grazing, even more placing around, and the idea of managing habitat. And we were interested in increasing forbs. And this is one of the places we were worried about. This is at a Corona ranch in central New Mexico. It's dominated by New Mexico feathergrass, and it's really rank. You can see it's kind of gray and red. We thought, hey, what if we graze this a lot? If we could get these cattle to stay there, remove the standing dead vegetation, maybe we could get some more access to nutritious forage and get a few more forbs. And that would be something Pronghorn would like. So we went and looked at it in some relatively big. This is a 2,200 and a 4,000 acre pasture, and we picked out 50 acre little spots, and some of them we considered targets. That would be the blue, and yellow were controls. And every week we picked a new target, 50 acre target. So on week 1 we were trying to get them here. Week 2 we were trying to get them here. Week 3 we tried to get them here. and in week 5 here, week 4 here, week 5 here, and week 6. Okay, so every week we're picking a new spot, and we're going to do everything in our power to get them to this target area. We're going to treat some vegetation. We put out low moisture blocks, we put out mineral mix, and we herded them there as often as we could. So we're trying to really put all our tables together to do something. We had 86 cows. We herded in late afternoon, about evening, so they had there. We used Bud Williams techniques, and we had to do it. We either did it daily for part of them, and we weekly, and you'll see that. Now the interesting part is that, like all research, doesn't come without its issues. In the first 3 weeks of the study is one of the most severe droughts you've ever seen in central New Mexico. And the second 3 weeks of our study, it was a great year, well above normal precipitation. So some of the ranchers said it was the best year and worst year in the same year. Kind of typical of New Mexico, I think, actually. So the first half was here, second half it rained. Now this is to show you what it did. So here we herded daily. We're watching one cow, kept the same cow on for 3 weeks, stays dry, herded there. And so look there, she's spending quite a bit of time in there. It's not the only place. Then we herded over here for a week, did it daily. And then we herded here weekly. Not as quite as effective. Then it rained. Then we herded them there, they didn't stay there. We took them there, and we took them there daily or weekly, but they just did not stay. Once the grass started to green up some of these lower areas, they collected a little more moisture early, and they went there. And we just weren't effective in manipulating where we wanted them to go. If you look at it here, so this is of all the time, so there's like a 4,000 acre paddock. They spent over like almost 35% of their time within a 50 acre paddock right at first. And another one was 30. So I spend 30% of their time inside a 50 acre paddock, inside of huge paddocks. So we thought, we're feeling pretty good. We didn't even do that bad when we only herded weekly when it was dry. Later on we took them there, but not much effect. And compared to our other areas that we consider to control, almost no time. So we're thinking we're a big deal. Notice that we measured the forb response. When we were effective in moving the cows, looks like we got a forb response in perennial forb cover. When we weren't, we didn't get one. So when you add it all together, not significant. But we're encouraged. When we looked at where the livestock, we had the cows GPS collared. We also had VHF collars on the Pronghorn. Now this is their distribution pattern, kind of hard to see. But like in the pre-treatment, post-treatment, notice there's quite a bit here, and when you analyze it statistically, they were just a lot closer to the target areas where we'd herded the cattle to, the pronghorn were, than you'd expect by chance. We think we made an effect. We saw when we were effective, we saw forb response, and the pronghorn appeared to respond to it. So we're really pretty excited about that. We think the implications of this case study is, strategic low moisture block placement and herding can be very effective, especially if it's dormant. When animals need that low quality, need some protein, they're really liking it. Man, it seems to be a powerful tool. And we even got a positive vegetation response from doing that. But it's just more of a case study. We're trying to get some more funding to carry this on because we think this is an exciting way to get some more use out of our livestock there. So we can really do some big things and moving animals around without having to have a fence. So I want to ask yourself, to what degree do we really, really need to control livestock grazing behavior? Do we really want to start breeding them with little handles on cows so we can just herd them around exactly where we want them? Is that what we really want to do? And secondly is, sometimes I think we really have to ask ourselves, even if they are selective, is it really, really that bad? It does allow them to pick a better diet. It allows them to avoid toxins and poisons. And it lets a heterogeneous structure emerge, for biodiversity and wildlife habitat. And we think that plant diversity is important. One of the things that I took this slide from a study that Joel Brown at the experimental Hornado Experimental Range, NRCS. He and I wrote this, and we're really thinking that really at the core of it, our rotational grazing systems really an attempt to reduce diversity. We want to treat everything the same. Is that really what they're about? I mean, we want to have the same species composition, graze the same seasonality, all those sorts of things, and get the same response from defoliation. Is that really what it's about? And do we want to increase evenness? Is that the purpose of them? I don't know. Something to think about. But I do think that sometimes is really selectivity all that bad? So, but we know that it can be bad, but so what can we do to alleviate it? Well, we certainly think that adjusting stocking levels to light to moderate levels is a big help. We really, if we're going to do that, if we're not going to put in a grazing system, we sure as heck better manage grazing distribution. And we probably really ought to think, if we can, rather than is to keep remembering to change the season of grazing. I mean, that's really the key, I think. The season of grazing, if you have a riparian area, make sure it's not grazed continuously, make sure you manage those animals away from it. Those are the things, active management. I think that's the king. And the idea is if we have that, is we can live with it, we manage it, and we can still prosper. So the last kind of rhetorical question I ask is, can we guide rather than force livestock to meet our management objectives? And with that, I'm ready for questions. Yes, in the back.
I've listened for about 3 years, the guys out in New Mexico State and the Coronado Station and that. And just what comes across every time is that you guys, now just throwing a big wide net here, assume that grazing system, you make some assumptions right there at the end that I don't think are true. One, grazing systems I work with, and I know a lot of my colleagues, aren't meant to get selectivity. We want just the opposite. Especially if you have a diverse vegetation composition, 10 or 7 or 8 grasses, a lot of forage. We want the selectivity. The grazing systems are set up that way to get selectivity. So I don't understand the assumptions made that when you put a grazing system together, that you're wanting selectivity. We don't want it to be selective. We don't want it to be homogeneous. We want it to be all-encompassing. That's why they get grazed at different times, so that we can get no selectivity, and we get a wide range of grasses, forbs, and shrubs out there. Instead of that, the assumption is made that all grazing systems are set up to get those two things. One, to be grazed homogeneous, just right down to the ground. Two, that we want them all to be grazed evenly. And that's not the case.
Well,
that's just a comment.
Well, I appreciate it. So the big thing is that are these rotational, are grazing systems meant for evenness? And you argue that they're not. But that's certainly one of the big measures of a successful grazing system is evenness of defoliation. And the thing is in the research, that's one of the things and one of the benefits that is proclaimed. But one of the things is that I do want to, that I hear you, but and I really think that's the case if you have I really can't overemphasize that I think that deferment of grazing during an active grazing season, active growing season once in a while is really a good deal. I mean, it really, that's really doing it. When you have a fast rotation, though, by definition, you're really trying to graze all paddocks in that time frame rapidly for a few days, maybe an hour. I mean, however way you're trying to do that in these intensive rotation systems, in theory, one of the theories is that's the case, and that's one of the things I think that's kind of a downside. Now, one of the things I think is there's really, remember the Brisky says there's really not much difference about it. If you like them, if it's working for you, too cool. But the thing is that I don't think that it's absolutely the key. That's my opinion. One of the things I think that is key, though, is especially if you have big differences in preference for grasses, some periodic rest during active growing season is a great thing to go do. Now, if you have riparian systems, man, if you don't do some either really intensive active management or you have some rotational grazing system, you're going to have a hard time managing a riparian system because the livestock love them. They're going to go to them. So that's another situation. When you have those in, I think it's it's going to really help things out. But I do think that the thing that probably bothers me the most, and probably why I'm going to speak most passionately about it, I don't think it's a necessary. I think a conservatively stocked paddock that's well managed with distribution can be every bit as good as one that's in there. And it's a lot cheaper. So if you don't want to be a recreational fencer, I think there's alternatives to that. And that's my pitch. I think there's lots of alternatives to that and still be thinking. Because I've seen a lot of paddocks, a lot of pastures in the West, and this is back to professional opinion, but I've wandered around a lot, and I've seen a lot of lightly stocked, extensive grazing with long grazing seasons that look really good. And you even really good next to water. And it doesn't fit the paradigm that we typically invest these things, that we need to rotate, we can't let them have access to them. I really think that I've seen a lot of them and they really look good. So that's my point, is that if you manage distribution, but those are lightly stocked, conservatively stocked, and where distribution is well managed. And I've seen some really good looking places like that. When there isn't riparian issues, especially. If you have a riparian issue, the riparian area still may be an issue. But still there. Yes, Roy?
What I've heard you say, Derek, is that when you're trying to create hill climbers by inducing them with low moisture blocks, when you take the blocks away, you haven't necessarily created hill climbers by experience.
Good question, but I must not have communicated well. Okay. Now, when we did the hill climber, we don't think we've created hill climbers by placing low moisture blocks. In fact, we've even looked at that. We looked at how effective is hill climbers, did low moisture blocks affect hill climbers versus bottom dwellers? And it turns out that they both works for both of them. Now, what we think is that it works great for both. It puts both of them up the hill. But we think that there are some inherent differences in those animals that allow them to be, that they express a phenotype. You go out and graze, some graze high, some graze lows. It seems to be consistent. And part of it we think might be genetic. We don't know how much. We'd love to find out. And obviously some of it is learned. Early experience is probably a big role. So we can take both things. We can use each one, and we think we get bang for the buck out of both. But we don't. The below moisture blocks don't create hill climbers. They just help both sets of animals get up the hill or where we want to put them.
What I was focusing on is the experience. So you show them the top of the hill, then without the inducement, will they go back?
The answer to that is yes. Once you take them away, the block goes empty. For example, the data. We have both anecdotal stories, and we have data. Like the data that we saw, once we took the blocks away, they just left the area. When we put we had collars on the same cow with blocks, without blocks. Take the blocks away, just leave solid up there, they don't go back. If we have anecdotal people that had really some good stories to tell us about how well it was working. As a producer in Montana, he said it worked really good. And he said, I wonder if it'll work without it. And because God, stuff is still expensive, and it's still still having to pay for it. He says, gosh, I bet they just learned it. And so the next year he didn't buy it. The next year they didn't go where he put them before. So the question is, so it's really expensive. So it's one of those sort of things. Think about it from the cow's perspective. What have you done? You have gotten her enticed her to go to a far place away, and once you've done that, you remove the problem of the travel. And so once you remove that problem, they'll graze nearby. If there's no reason to go back out there, she might not, unless there's on that idea. Other questions? Joel.
Derek, you didn't really talk much about aspect. And how much of a confounding factor is that, both for research and management? What do you do to overcome it?
On aspect. Aspect can play a big role, especially when it's cold or it's hot. When it's cold, you can get animals are going to prefer south slopes. Man, I still think that's true. So temperature on aspect can play a big role, and you can do that. Secondly, there's different species composition with aspect as well. So one of the ways to do that is to change different seasons of grazing. You can take advantage to have them focus on an aspect that they like in a certain season as opposed to not. I think you can take advantage of aspect by changing the season of when you graze, or perhaps use other techniques. If you have an aspect that's not getting grazed like you could herd them to them. You could put supplement low moisture blocks there. There's lots of things that you might be able to take advantage, but it surely does play a role, often a lot with temperature and also just inherent species composition and when it starts to grow. Does that answer your question, Joel? Yes?
Have you ever culled bottom dwellers? Careful.
Careful.
Have you ever culled the bottom dwellers to see if you can turn hill climbers into bottom dwellers?
Okay, we did do that. So what we did is we did a study where we separated them to simulate that kind of heavy-duty culling. So we took the hill climbers that had been hill climbers for 2 years, and we took when they were all in the same pasture, and the bottom dwellers, we separated them, and then the hill climbers continued to keep using the slopes. The bottom dwellers kept staying on the bottom. Now, because there's, Jeff Mosley at Montana State, he argued that the culling of the bottom dwellers wouldn't work, because as soon as you got rid of those that were at the bottom, the hill climbers would just come down and fill in that vacuum. Very good question. I mean, really, it made a lot of sense. We tested that, and they still went up there. So can you? But if you take away the hill climbers, all of a sudden do bottom dwellers become hill climbers? The answer is probably not. I think it's other things that are going on with that.
So did you train the cows, or did the cows train you?
Oh yeah, cows probably trained me, but we did have some big progress. We had some big progress with the herding. I mean, I think it's I get excited about it, obviously, but I think you can make some big difference by taking advantage by using herding and supplement. You can make some other things happen, and especially, I mean, like Dr. Provenza's, he'll be telling about that tomorrow. Is that you change their early life experience, it can make a big difference, and we think that maybe genetics can play a big role, and we're real excited about it because it'd be relatively less expensive and easier if we could, if we find the marker for hill climbing, genetic marker. Man, I think it's going to be really cool. So we're trying to think about that sort of thing.
Any more questions for Derek? All right, we appreciate it, Derek.
Thank you.